Hello everyone. In this video, I'd like to solve this example from the homework. In this case, we have a geometric series. We have the geometric series are sums, infinite sums, whose general term is a geometric sequence. And why do we know this is geometric? Well, it's a constant to the n, so it's a geometric series. In the first part of these types of questions, we are asked to find what is S sub 100, S sub this number, and S sub m, the partial sum in general. So to do that, we just have to remember that in general, the partial sum means add to that term. So, for example, S of 100 means that we start adding from the first term here, which is 3. So that's minus 4/7 to the third power plus the next one. And what's the next power? Well, it's the one after 3, it's 4. Okay. And so on and so forth until we get to the one indicated here, which is minus 4/7 to the 100th power. Okay. What we do next is that we multiply the common ratio. This means that we multiply by minus 4/7 the whole sum, and we get the following. Well, S of 100 times minus 4/7 gives us this. Let's see. So let me move all of these guys here. And this 3 becomes a 4, this 4 becomes a 5, and I'll do another term at the end. Let's see. So this is 4, 5. And so this is what minus 4/7 to the 99th power became. And then we just add the multiplication of minus 4/7 times once more to the 100th power, and we get a 1. I mean, we get 101. Okay, so this guy corresponds to this guy corresponds to this, and this one corresponds to this. This one appeared because I did not add the 99th power here. Now, there are a lot of things which are common between this sum and this sum, so to get rid of them, we will subtract one from the other. How do we do that? Well, we take this guy, S of 100, minus this amount over here. And so, guys, look at that. We get a cancellation of all of these guys with all of these guys. Okay? And what we're left with is the initial term, well, the first term in the sum, minus the last term of this sum. Okay? Why is that? Because let me just write it down here to be more clear. This minus this amount. So let me put it like this. What we're doing is that we're canceling everything here. Please pardon me. And so we have these guys which cancel each other out. And we're left with just this guy minus this guy. Okay, wait, I did not want to do that. Okay, and so that's that, no? So we can separate, factor the S100 here in order to obtain this expression. So this over 1 minus this amount. So this is 1 minus 4/7. Okay, and that's it. This is the number which is equal to that partial sum S of 100. In the case of S9999999, we have to do the same. In order to get full credits in these types of problems, you have to do this whole process once again. I know it's similar and it might even be tedious, but that's just how it is, guys. We take the whole sum, but instead of 100, we now put this huge exponent over here, 99999, and then we get that we again multiply by the common ratio, and we get the sum from 4 to the last power plus 1, so that would be minus 4/7 to the 100,000 power. And so when we subtract, this means that we get this guy minus this other guy. Oh, look at that. I forgot the sub-index here. This guy. And we subtract these two guys. And we're left with, once again, with the initial term and the last term. Okay. And so we just factor a S9999999 out. Hey, I didn't want to do that. I wanted to use this guy. So our sum, our partial sum up to that number is this, once again, over 1 minus 4/7. This is a perfectly acceptable answer. Okay. Wonderful, isn't it? Finally, for SM, we have to do the same, but I'll leave that part to you. I'll write it as verify, which means you still have to do this process to earn the full credit. You have to verify that SM is equal to minus 4/7 to the third power minus 4/7 to the m plus 1, sorry, lowercase m plus 1 over 1 minus 4/7. If you only put the formula without doing the whole process, the answer will not receive full credit. So in this case, you will have to do, to obtain this process. Okay, I know it's just tedious writing, but that's just how it is. And now based on that, we may determine the behavior of our whole sequence, our whole series, by considering the limit as m goes to infinity of the partial sum. Oh, is determined, determined by S sub m. So we just consider the limit as m goes to infinity of S sub m, and S sub m is this guy. This is the same as the limit of this amount. Okay. And so, guys, let me write it like this. S is the limit of the partial sum sequence. And so, guys, we may do algebraic properties. Since this is constant and this is constant, then the limit only cares about this. And so we may write this as this amount minus the limit as m goes to infinity of, well, this guy, right? Beautiful. And so, guys, the important thing about this thing here is that minus 4 over 7 is a fraction which is less than 1. Okay? So as it's less than 1, the fraction's powers tend to 0, right? So this means this is equal to minus 4 over 7 to the third power over 1. I'll just put it plus 4 over 7 like that. Okay? And so this means that S converges to that amount. S converges to this quantity. It's okay if you don't simplify, there's no problem with that. And with that, we have solved the exercise. So basically, in these types of exercises, you will see that there is a sum, partial sum, which you have to compute. To do that, you do the whole sum and then subtract one from the other after multiplying the sum by the common ratio. Then you solve for the partial sum and you get a formula. The same thing with the next subindex. And in general, you have to do this for a general m. But it's the same process that we did here. And finally, to find the behavior, to determine the behavior of the series, you just take the partial sums limit, and that's that. Okay? So as a final observation, if the series starts at 0 or starts at 1 or whatever, well, let's see, at n equals 0, for example, then, for example, in this case, because remember that we had that the series here started at n equals 3. So in this case, if it started at n equals 0, then this means that S of 100 would be something like, let's see, something like this. Let's see. That would be 0, 1, 2, 3. So let me just add another guy here. So our sum would look something like this. 0, 1, 2. And so we would just have to start at 0, which is most of the problems. I just wanted to pick out this one because it had a different starting point so that you guys would see an example of what happens when the starting point is different. But in most cases, geometric series will look like this and will start at 0. Okay? And the process is literally the same. The only term that survives is the initial term minus the last term and so on. Okay? So thanks for watching. And if you have any questions, please let me know.